Hi everyone, this is T. Ramesh, Assistant Professor, Department of Mathematics, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. Through this lecture video, we are going to discuss about the topic test of hypothesis. In this test of hypothesis, we have the large sample test. Introduction. First of all, what is population? Population in statistics means the large number of data. The population is finite or infinite according to the number of elements in the set is finite or infinite. A set has finite number of elements or infinite number of elements. The large number of elements is called the population. Next, what is sampling? A part selected from the population is called sample. So what are the process of selection? That selection is called sampling. Parameters. So what is parameters? It's like a population and it's a part is sample. From that, what is parameter? The statistical constants of the populations such as mean mu, standard deviation sigma, these two are called parameters. These parameters are denoted by the Greek letters. Statistics. What is statistics? The mean x bar, standard deviation capital S of a sample are known as statistics. What is the difference of parameters and statistics? Parameter is population mean and population standard deviation. These two are parameter. Statistics, the sample average and the sample standard deviation, these are statistics. Next, what is standard error? Standard error in the standard deviation of the sampling is called standard error. Precision. The reciprocal of this standard error is called precision. Next, what is test of hypothesis? On the basis of sample information, we have some of the decision about the population. In taking such decision, we make certain assumption. These assumptions are known as statistical hypothesis. These hypotheses are tested. Assuming the hypothesis correct, we conclude the probability of getting the observed sample. If this probability is less than a certain assigned value, the hypothesis is to be rejected. So here we have two hypotheses. One is null hypothesis, another is alternative hypothesis. What is null hypothesis? Null hypothesis is based for analyzing the population. Null hypothesis is a hypothesis of no difference. Thus, there is no significant difference between observed value and expected value. So we shall test whether this hypothesis is satisfied by the data or not. If the hypothesis is not approved, the difference is considered to be significant. If the hypothesis is approved, then the difference would be described as due to sampling fluctuations. So, null hypothesis is a given data. We check whether is there any significant difference or not. That is null hypothesis. Alternative hypothesis, which is complementary to the null hypothesis, it is denoted by H1. Null hypothesis is H0. Alternative hypothesis is H1. The next, critical region. A region corresponding to a statistics data in this sample space capital S, which assumes or take amounts to rejection of the null hypothesis H0 is called a critical region or region of rejection. The region of sample space S which amounts to be acceptance of H0 is called accepted region. So what is critical value of significant value? The value of the test statistics which separates the critical region from the acceptance region is called critical value or significant value. So what are the level? What are the level of significance? The probability that the value of the statistics lies in the critical region is called the level of significance. In this normal value, we reject some of the data. From the data, we need some of the conclusion from the significance. So what are the data needed from the rejected data? So how much data are there? We take some 1% data to take or 5% data to take for analysis. That is called the level of significance. Here we have two level of significance. One is 1% and 5%, or 0.01 level or 0.05 level of significance respectively. So another one is error. Here we have the important type 1 error and type 2 error. So what is type 1 error? If the null hypothesis is rejected when it should have been accepted, then it is type 1 error. Or what is type 2, and what is type 2 error? If the null hypothesis is accepted while it should have been rejected. So from this table we have what is accepted and rejected. So accepted H0 and H0 is true. If the null hypothesis is true and we accept the null hypothesis, then it is correct decision. If null hypothesis is true, we reject that, then it is type 1 error. Next, what is type 2 error? If the null hypothesis is false but we accept that null hypothesis, then it is type 2 error. If null hypothesis is false, we reject the null hypothesis, then it is correct decision. So what are the test of significance? The test of significance are a test for significance for large sample, the test based on for small sample. If the sample size is greater than 30, then it is called a large sample, like binomial, Poisson, etc., or approximated by normal distributions. Thus, normal probability curve can be used for testing hypothesis. For larger samples, compute the test statistics model is Z, then it is called result is follows. If the calculated value is less than 1.96, we accept a H0 at 5% level of significance. If the calculated value is greater than 1.96 at 5% level, we reject as null hypothesis. If the calculated value is less than 2.58 at 1% level, we accept null hypothesis. If the calculated value is greater than 2.58, we reject null hypothesis at 1% level of significance. So test of significance for a single mean. We discuss one problem based on this test of significance for single mean. The problem is a sample of 400 individuals is found to have a mean height of 67.47 inches. Can it be reasonably recorded as a sample from a large population with a mean height of 67.39 inches and a standard deviation 1.30 inches? So what's the question here? 400 individual data, and its average height was 67.47 inches. So the large populations, we conclude from that we have the large population mean height is 67.39 inches and the standard deviation 1.3 inches. That is our question. Okay, we deal that. What are they given? The n is 400 data. The average of the sample is 67.47. The mean average height is sample height is 67.39 and the standard deviation is 1.30. So what is null hypothesis? There is no the sample is taken from the large population. So mu is equal to 67.39. Let us assume that what is null hypothesis? Assume there is no significant difference between sample mean and population means. We test the statistics. So what is test statistics is absolute value of or modulus value of x bar minus mu divided by sigma by root n. Already given the sample population mean is 67.47, sample mean is 67.39 and the standard deviation is 1.30. Number of data is 400. Substitute all that. After it is that we get 1.23. It is our calculated value. At 5% level, the tabulated value is 1.96. Here, the calculated value is less than table value. Therefore, we accept the H0. Therefore, our conclude the sample has been drawn from this population. We discuss one more problem. The two samples of cables of sizes each 100 are taken in order to test the breaking strength, and their mean and standard deviations are given. In the cable 1, the mean is the number of data. This number of cables are 900 and 109.25 and the standard deviation is 40, and second cable is the mean value is 1095 and the standard deviation is 30. From the given data, we test whether the mean breaking strength of the two cables are equal at 1% level of significance. Here there are two different mean and two different standard deviation and two different data. So we have differed that first we assign the null hypothesis. There is no significant difference between the mean and the breaking strength of two cables. So level of significance is 1%, that is 0.01. So computations of this test statistics is the difference between the two means x1 bar minus x2 bar divided by root of sigma 1 square by n1 plus sigma 2 square by n2. The first average is 1009.25 and the second average is 1009.5 divided by standard deviation of first data is 40, therefore 40 square divided by number of data is 100 plus second data standard deviation is 30, so 30 square by 100. After reduce that, we get the value is 4. Here the tabulated value of Z at 1% level of significance for two-tailed test is 2.58, but our calculated value is 4. Tabulated value is 2.58. Since this calculated value is greater than table value, therefore null hypothesis is rejected. So from this we conclude that the mean breaking strength of the cables differ significantly. So these are all the references, statistics methods by S.P. Gupta, Sultan Chand and Deepak Printers, 2014 New Delhi. Thank you.